Okay, welcome back. The business optimization section so far has centered on maximizing profit. We're going to look now at another type of problem that is, instead, we're going to minimize average cost per unit. And it ends up requiring a formula we haven't used yet. So a company makes solar panels and estimates the total cost of producing X solar panels is given by C of X is equal to the fixed costs, 200,000, plus the variable cost, 300X plus 5X squared. So that's our variable costs. The 200 is our fixed. How many solar panels should be made to minimize average cost per unit? So now we need the definition of the average cost per unit, which is on the previous one of the previous slides. Definition: average cost per unit, C bar of X is equal to C of X divided by X, which is this whole thing there. Not 3. What am I doing? 200,000 plus 300x plus 5x squared, all divided by x. So 200,000 divided by x plus 300 plus 5x. Dividing each piece by x using that rule for fractions. So I'm going to rewrite it over here. C bar of x is equal to 200,000 x to the power of negative 1 plus 300 plus 5x. We're going to take the derivative. Well, I should write do calculus. Do the calculus thing. So take the derivative, we get negative 200,000 x to the power of negative 2 plus 0 plus 5. We set the derivative to 0. Negative 200,000 over x squared plus 5. I'm going to add 200,000 over x squared to both sides and move that piece over to the left. Then I'm going to cross multiply both sides by x squared. And then I'm going to divide both sides by 5. So x squared is equal to 200,000 divided by 5. So if it was 100,000 divided by 5, that'd be 20,000. So this is going to be 40,000. So x is going to be, keeping in mind that we can't take negatives, we're going to take the positive root only. So x squared is equal to 40,000. So x is equal to plus or minus the square root of 40,000. Which is 200. I think, because 200 times 200, 4, 0, 0, 0, 0, 4 zeros. Yeah, okay, good. Okay, made a good question. We cannot have negative solar panels, so we throw away this solution. No negative solar panels. Is this a max or min? So I'm going to take the second derivative of the average cost, C double prime, C bar double prime, I mean, C bar double prime is 400,000 x to the power of negative 3 plus 0. And then we evaluate this at 200. It's going to be some gigantic number, 400,000 divided by 200 cubed, which is positive. So it's concave up. So it is a min. X equals 200 is the min. And we're after the min. We're looking to minimize this cost. All right. Next question. Same setup, except it's cat costumes. A company manufactures cat costumes and estimates the total cost of producing X costumes is given by 12,500 plus 3X plus 5X squared. How many costumes should be made to minimize average cost per costume? So we're going to start the exact same way. We're going to make our average cost function, C bar of X, is C of X divided by X. So we have 12,500 over X plus 3 plus 5X. We're going to take the derivative of this function, C bar prime of X is equal to, and actually let's rewrite this as 12,500 x to the power of negative 1 plus 3 plus 5x. So we don't have to use a quotient rule, just use exponent laws to rewrite that denominator term. Take the derivative, we get negative 12,500 x to the power of negative 2 plus 0 plus 5. We set the derivative equal to 0. So negative 12,500 over x squared plus 5. I'm going to add that first term to both sides. 12,500 over x squared is equal to 5. Cross multiply by x squared. 12,500 is equal to 5x squared. Then divide both sides by 5. That's 625. No. 1 second. Let's see. 600, yeah, 625. And that means we're going to get two solutions. X is equal to the square root of 625 and x is equal to the negative square root of 625. But that second one, we cannot have negative cat costumes. Hey, where'd my cat go? She disappeared. She was here. There's no escape from this room. I don't know how she got out. I'm legitimately frightened. Maybe she heard cat costumes. I'd leave too. Cannot have negative cat costumes. So it's got to be 625 square rooted, which is 25, I think. 25 times 25. Looks good. Okay. Times 5 is 125, times 5 again 6. Okay, yeah, that's good. Now we have to make sure it's a max, or we have to make sure it's a min. Is it a max or min? So we're going to take the second derivative of the average cost. So we have negative 2 times negative 12,500 x to the power of negative 3 plus 0. So we're going to get 25,000 over x cubed. Now we're going to evaluate this at 25. Now we don't actually have to plug anything in. We just have to check is it positive or is it negative. 25,000 divided by 25 cubed is a big, maybe not that big. It's a positive number. All that matters is it's positive, so it's concave up at x equals 25. Thus, min average cost at x equals 25. I'm going to go back here, make sure I put that is the min. Okay. I'll circle that, and that's the answer. So one thing to caution you about is when you do these types of questions, pay attention to whether or not you're asked to minimize a cost or minimize an average cost. If it's minimizing a cost, you take the derivative of the function set equal to 0, which is like minimizing or maximizing a profit or revenue. If you're asked to minimize an average, you have to divide the expression by x first to get the total, like take the total cost divided by the number of units that you make. That gives you the average cost per unit. And then you want to minimize that. So you have to read it carefully. And that is the end of this section. See you next time.